In the late 19th century, the world believed reality had already been measured. Steam engines roared across continents, telegraph wires stitched nations together, and physics, so it seemed, had finished its work. Nature was thought to be fully explained, its secrets neatly catalogued. Yet inside a quiet laboratory, an experiment was about to do something dangerous. It would not discover a new force, it would erase one. And in doing so, it would force science to confront a terrifying possibility, that reality itself had been misunderstood. By the 1880s, energy was the language of progress. Light, heat, motion, everything could be reduced to equations, flows, and forces. At the center of this confidence stood a concept known as the luminiferous ether. According to the most respected scientific minds in Europe and America, light was a wave, and waves required a medium. Sound moved through air. Water waves moved through oceans. Light, it was believed, moved through an invisible substance filling the universe. The ether was not questioned, it was assumed. Textbooks taught it. Professors defended it. Entire careers were built upon it. This belief shaped how scientists understood energy itself. Light was energy in motion, and motion demanded something to move through. The ether became the unseen stage on which all electromagnetic phenomena performed. It was elegant, comforting, and wrong. In 1887, at the Case School of Applied Science in Cleveland, two American physicists prepared an experiment that seemed almost trivial. Albert A. Michelson, a meticulous naval officer turned scientist, and Edward W. Camley, a quiet, deeply religious chemist, were not revolutionaries. They were precision men. Their goal was simple: to measure Earth's motion through the ether. Their device was an interferometer, an intricate arrangement of mirrors and beams of light mounted on a massive stone slab floating in a pool of mercury. The laboratory smelled of oil and metal. Outside, horses and carriages passed along dusty streets, unaware that inside, reality was under inspection. The experiment relied on a simple idea. If Earth moved through the ether, light traveling in different directions should move at slightly different speeds, like swimmers battling a current. Michelson had already attempted this once and failed to detect the ether. This second attempt would be more refined, more sensitive, more precise. There was quiet confidence that this time the ether wind would finally reveal itself. As the apparatus rotated, light beams split and recombined, producing interference fringes, delicate patterns that should shift if the ether existed. Michelson and Morley watched closely. They recalibrated. They repeated the measurements at different times of day, across seasons, accounting for Earth's orbital velocity. Days turned into weeks. Nothing changed. The fringes refused to move. The result was not merely unexpected, it was devastating. The ether, the invisible carrier of light energy, appeared not to exist. The speed of light remained stubbornly constant, indifferent to Earth's motion, defiant of classical physics. Michelson was unsettled. Morley was troubled. They published their findings cautiously, almost apologetically, in the American Journal of Science. There was no triumph in their tone, only confusion. Across the Atlantic, the scientific world hesitated. Some dismissed the result as experimental error. Others proposed increasingly elaborate theories to save the ether, twisting it, compressing it, dragging it along with Earth like a cosmic afterthought. The experiment had not yet overturned reality, but it had cracked its foundation. This was a period of immense cultural tension. Empires expanded, factories multiplied, faith in human mastery over nature was at its peak. Yet beneath the surface, uncertainty spread. If light, pure energy, did not behave as expected, what else had science misunderstood? A young patent clerk in Switzerland read these papers years later. Albert Einstein was not present in that Cleveland laboratory, but the ghost of Michelson and Morley haunted his thinking. In 1905, Einstein published a paper that did the unthinkable. He abandoned the ether entirely. Instead, he proposed that the speed of light was constant for all observers and that space and time themselves must bend to accommodate this fact. Energy was no longer just something that moved through space. It was bound to space and time, woven into the fabric of reality. Mass could become energy, time could slow, length could shrink. The universe was no longer absolute. The Michelson-Morley experiment did not shout, it whispered, yet its silence spoke louder than any discovery before it. By failing to detect the ether, it forced science to rethink not just energy, but existence itself. Classical physics collapsed, not from explosion, but from absence. Today, the original interferometer no longer spins in mercury. Satellites now test relativity with atomic clocks. Lasers measure space-time ripples from colliding black holes. Yet every modern experiment stands on that quiet moment in 1887 when light refused to behave. Some historians compare the ether to mythological aether, the divine substance believed by ancient Greeks to fill the heavens. Its death marked the end of a comforting cosmos and the birth of a stranger one. As museum archives and university records confirm, this experiment remains one of the most important null results in scientific history. Less reliable popular accounts dramatize the moment, but the truth is subtler and more powerful. Science did not advance by proving something existed. It advanced by learning that something did not. If this experiment changed how we understand reality, imagine how many others still wait in silence. Subscribe to the channel for cinematic science stories that reveal how experiments, not accidents, reshape the universe we live in.